So today we are discussing some properties of expectation. Okay. So let us consider a less than or equal to x less than or equal to b almost surely. Then clearly we know that this is a less than or equal to expectation of x less than or equal to b. Okay. Now what is expectation of x for arbitrary random variables? So that is nothing but ഇവിടെ കഴിഞ്ഞ ദിവസം നമ്മൾ കണ്ടിരുന്നു അല്ലേ? x dp equal to integral x minus. Okay, so that means note. Okay. So by applying this inequality, we can ഇത് രണ്ടും പോസിറ്റീവ് എക്സ് പ്ലസും എക്സ് മൈനസും പോസിറ്റീവ്. X plus is positive, so integral x is also positive. So this is equal to expectation of result here. Now we have this result. We have already proved this result in some previous class. That is, if p of xi equal to I equal to pi, then expectation of x is equal to, you know that this is summation I from 1 to n I into pi. That is p1 plus p2 plus etc. pn plus etc. 1 into p1 plus p2 plus etc. pn plus 2 into that is 1 into p1 plus 2 into p2 plus 3 into p3 plus 4 into p4 plus etc. p1 plus 2 plus like this. That is p1 plus p2 plus etc. അങ്ങനെ ഒരു സെറ്റ് ആയിട്ട് എടുത്തു. Then 2p2. So from that we take another p2. That is p2 then 3p3 is there, so we take start from p3 plus p4 plus etc. Okay, so you can proceed like this. So that is given here, p1 plus, so that is, so this is actually p1 plus p2 plus p etc. That is p of x greater than or equal to 1. That is the x value takes 1, 2, 3 etc. So we can write it as p of x greater than or equal to 1. The second time is starting from second x value, that is p of p2 plus p3 plus etc. So it is nothing but p of x greater than or equal to 2. The third bracket, it is start from third term. So p3 plus p4 plus etc. That is p of x greater than or equal to 3 plus etc. So you can summarize like this: summation n from 1 to infinity p of x greater than or equal to n. So this is for non-negative random variables. If x is non-negative, then instead of expectation of x equal to summation I from 1 to infinity I into p, we can write it as summation n from 1 to infinity p of x greater than or equal to n. So that is the discrete version of this continuous result. I think we have already proved this continuous result for continuous part, continuous random variables. So I am not repeating, we have already proved in some previous class. Now we can represent I think this is one of the given. Seminar I have given to the first seminar. I think this is first seminar, so she will take the seminar. Two random variables x and y, and we considering it Borel Bessel function g of x comma y on x comma y. Then expectation of g of x comma y is equal to integral over omega g of x comma y dp. Okay, it is defined on this g is defined on the bivariate space, that is R2 B2 Pxy. So that is a probability space in which the random vector x comma y is defined. Okay, so you can represent like this: expectation of g of x comma y equal to integral x comma y dpxy. Then instead of dpxy you can write it as dfxy. So that is integral over R2 gx comma y df of xy, d capital F of xy. If it is differentiable, that is if f is absolutely continuous, we can write like this: instead of df of x we can write f of x comma y dx dy. If it is differentiable only, that is required condition. Okay, so this is the expectation of function of random variable, expectation of x comma y. Okay, that is trivial. Now we consider the expectation of a complex random variable. You know what is a complex number? Suppose z is a complex number that can be represented as x plus iy, where x and y are real numbers. I is equal to root minus 1. Then you can represent the real complex number set of omega as rho of omega and e raised to I theta of omega, where rho of omega greater than or 0 and theta lies between 0 and 2 pi, that you know. Now so we can define expectation of z equal to expectation of x plus I into expectation of y. So when expectation of z exists, if expectation of x and expectation of y exist, then expectation of z exists. That is, z is integrable if and only if x and y are integrable. Now we can reduce, or we can rewrite the equation like this. Suppose z equal to e raised to I ux. Okay, z equal to e raised to I ux. Then I ux can be written as cos ux plus I sin ux, where u is a real number. So what is the so this is nothing but if you take the expectation to z, that is nothing but the characteristic function. So we denote like this: phi x of u, that is characteristic function. Phi x of u is equal to expectation of z, that is expectation of cos ux plus I into expectation of sin ux. Phi x of u is equal to integral over r e raised to I ux df of x. That is the formal definition. So that is using the right side, you can write it as integral over r cos ux df of x plus I into integral sin ux df of x. So this phi of x is called a characteristic function. And so that is the representation. Now we consider this result. If z is a complex random variable, then modulus of expectation of z less than or equal to expectation of modulus of z. So we can prove easily. Take z is equal to rho into e raised to I alpha, where rho and alpha being random, then expectation of z equal to some r into e raised to it. Suppose we are writing like that. Okay. Then expectation of z equal to modulus of expectation of z is equal to e raised to it. E raised to it is nothing but cos t plus I sin t. So mod value of that e raised to it will be 1. So expectation of mod z will have modulus value only r into 1. Okay. So that r you can write it as actually this what is that rho is nothing but instead of rho you can write it as this r is, so you can move this r into the left side or move this e raised to it to the left side. So what will be r? E raised to minus it into expectation of z. E raised to minus it into expectation of z. So r equal to e raised to minus it into expectation of z. But we have taken z equal to rho into e raised to I alpha. So we have used expectation of rho into e raised to I alpha. So you can take this e raised to minus it inside. So that is expectation of rho into e raised to I into alpha minus t. Okay. So that is simplified form. So you can apply this trigonometric expression. So this is expectation of rho into cos alpha minus t plus I expectation of rho sin alpha minus t. So this is equal to expectation of rho into cos because we have proved that this is real part, left side is real, r, this is r, real, so we can remove this imaginary part. So we use only real part, expectation of rho into cos alpha minus t. But you know that the maximum value of cos and sine trigonometric functions are 1. Sine will have maximum value 1, cos will have maximum value 1, so we can replace with 1. So this is expectation of rho. Okay, so what is rho? Rho is actually expectation of modulus of this mod value, because we have taken z equal to rho into e raised to I alpha. Therefore mod of z value will be rho. So expectation of rho. So you can replace rho with mod z. Okay. So this is expectation of mod z. Okay. So we have obtained the result is modulus of expectation of z less than or equal to expectation of mod z. Okay. So that is very interesting result. You can work out this result in your notebook. Okay. Now another result is if z is complex, z is integrable if and only if mod z is integrable. Okay. So from this previous result, that is expectation of modulus of expectation of z less than or equal to expectation of mod z. Okay. If mod z is integrable, this expectation will be finite. Okay, expectation of mod z will be finite. So automatically left side will be finite and expectation of z will be finite. That is z is integrable. Okay, that is the idea. So as modulus of expectation of z less than or expectation of modulus z implies mod z integrable implies z is integrable. Okay. Now we conversely we suppose that mod z is integrable. Okay, sorry, z is integrable. Conversely suppose z is integrable. So what is mod z? Mod z is nothing but if z is x plus iy, then mod z will be root of x square plus y square. But we know that from mathematical inequalities, root of x square plus y square is less than mod x plus mod y. Okay, but mod x plus mod y is mod z. Okay, mod x plus mod y is what is that? Sorry, root of x square plus y square less than mod x plus mod y. You can apply expectation to both sides. That is, expectation of less than or equal to expectation of mod x plus mod y. Okay, since this z is integrable, we have the condition z is integrable. Then naturally the real part x and imaginary part y are integrable, because the entire complex function is integrable. So x and y are integrable. Since x and y are integrable, we can say that mod x and mod y are integrable. Okay, mod x and mod y are integrable for the real, because x and y are real values. So that is non-real. So mod x and mod y are integral. So naturally expectation of mod x plus mod y will be finite, because expectation of mod x is finite and expectation of mod y is also finite. So naturally the sum of two integral functions will be again integral. So this is right side, this right side is integral. So naturally the left side is integrable. So that means mod z is integral. Okay, so that is the result. Okay, now okay, ഇത് നിങ്ങൾക്ക് ക്ലിയർ ആണെന്ന് വിചാരിക്കുന്നു. Now we consider, we have already proved some this type of inequality. We know all these inequalities. This we have variance greater than or equal to 0. Variance means expectation of x minus expectation of x square. That is expectation x square minus expectation x whole square, that greater than 0. So another moment generated function. You know what is moment generated? M of theta is equal to 1 plus expectation theta, expected x into theta plus expected x square into theta square by 2 square plus etc. And you know, this is the format of moment generated function. And you know that if we differentiate moment generated once and put theta equal to 0, you will get first raw moment. If we differentiate the moment generated twice and put theta equal to 0, you will get second raw moment, and so on. So that is non-result. We can apply that result here. Some examples are there. Negative binomial, then continuous gamma distribution. We can apply this. You can take this density of gamma distribution and find out the moment generated version. This trivial result. You know, you might have studied in distribution studies. Okay. So expectation of x, variance of x. So I am not going to that problems. And we also we have already discussed this lemma, so I am not repeating that. Yeah, we can consider this CR inequality. This is new one. Okay. So this result is expectation of x plus y raised to r less than or equal to CR into expectation of mod x raised to r plus CR into expectation of mod y raised to r, where CR equal to 1 if r less than or equal to 1, and 2 raised to r minus 1 if r greater than or equal to 1. Okay, so let us prove this inequality. Suppose a and b are two positive numbers. Clearly, this a by a plus b raised to r, that will be a positive number, and b by b plus a plus b raised to r will be also a positive number, and sum of these two terms will be greater than or equal to 1, because the maximum value of this is inequality. Okay, so mathematical inequality. So from this you can take the denominator a plus b raised to r to the right side, so you will get a raised to r plus b raised to r greater than or equal to a plus b raised to r. Okay. You can substitute and for r less than or equal to 1, you can replace with a with x of omega. and b with the y of omega. So what happens? Mod x raised to r plus mod y raised to r greater than or equal to bracket mod x plus mod y all raised to r. Okay, but you know that by triangle inequality, you know the triangle inequality. What is triangle inequality? Mod x plus y less than or equal to mod x plus mod y. So instead of this mod x plus mod y, you can replace with the smaller term mod x plus y. So that will be greater than or equal to mod x plus y raised to r. Now we consider a mathematical function phi of p is equal to p raised to r into 1 minus p raised to r, comma r greater than or equal to 1. And okay, so from equation 5.56 you can easily say you can apply the expectation to both sides, expectation of mod x raised to r plus expectation of mod y raised to r. For r less than or equal to 1. So you can apply expectation to both sides. So you have this result. Okay, this is the equation 5.52 with r equal to 1. Sorry, cr equal to 1. Okay. Now to prove the second, if cr equal to 2 raised to r minus, what happens? So take this mathematical function phi of p is equal to p raised to r plus 1 minus p raised to r. So you know, if you differentiate with respect to p and equating to 0, you will get p is equal to 1 by 2. Okay, if you differentiate phi of p with respect to p and equating to 0, you will get p is equal to 1 by 2. So p will be the minimum value, the optimum value will be attained at p is equal to 1 by 2. Okay, so you can say p raised to r raised to r plus that will have minimum value. This is nothing but phi of p. Okay, this will have minimum value. Then 1 by 2. Okay. And p is equal to 1 by 2. So 1 by 2 raised to 1 by 2 raised to r plus again 1 by 2 raised to r. Okay, ഇത് വരും 1 by 2 raised to r plus 1 minus 1 by 2 raised to, that is equal to 2 by 2 raised to r, that is equal to 1 by 2 raised to r minus 1. Okay, that is 2 raised to minus r minus 1. So that is given here. So you can replace this p with a by a plus b, then automatically what will be q, 1 minus p, that will be b by a plus b. So a by a plus b raised to r plus b by a plus b raised to r greater than 2 raised to r minus 1. So you can take this 2 raised to r minus 1 to left side. So that is 2 raised to r minus b, a raised to r plus b raised to r greater than a plus b raised to r. We can move the denominator a plus b raised to r to the right side. Okay, so you will get this equation 5.57. Then you can replace a with mod x and b with mod y, and right side mod x plus mod y using this triangle inequality, again you can replace this mod x plus mod y with the minimum, the lower value mod x plus y. So this will be, so you will get equation 5.5, 2 raised to r minus n mod x raised to r plus mod y raised to r greater than mod x plus mod x plus y raised to r. You can take the expectation on both sides, you will get the result like this. Okay, നമുക്ക് കിട്ടിയിരിക്കുന്നത് ഇങ്ങനെയാണ്. ഇവിടെ ഒരു 2 raised to r minus 1. Okay, so if you take the expectation on both sides, you will get 2 raised to സെയിം ഇക്വേഷൻ ആണ്. ഇവിടെ 1 വന്നു, ഇവിടെ 2 raised to r minus 1. ഇവിടെയാണ് ഇവിടെ മൈനസ് ആണ്, അപ്പോൾ അത് ഇങ്ങോട്ട് മാറ്റിയാൽ okay. So this is CR inequality. Okay, you obtain this 5.52. Then Holder's inequality, we already proved that inequality, and I'm not going again. Minisco's inequality, proved. Yeah, this one we can consider convex function. So what is convex function? A function, a real valued function, Borel measured function, if is said to be convex, if for every pair of points x and x dash on I, f of x plus x dash by 2 less than or equal to half into f of x plus half into f of x dash. So this is the format of convex function. Okay, so convexity is actually nothing but if the second derivative is positive. Okay, second derivative positive means what is that? Some I will show one graph. Of alpha 1 plus അതിൻ്റെ വേറെ ഫോർമാറ്റ് ഇവിടെ എഴുതിയിട്ടുണ്ട്. So an alternative definition for convex function is for a real number lambda of x naught, there exists a real number lambda of x naught such that lambda of x naught into x minus x naught less than or f of x minus f of x naught. That is another alternative definition. So we have an inequality using this convex function. Okay, ഇതൊരു ലീനിയർ ഫോമാണ്. ഉദാഹരണത്തിന് ഈ ഒരു പോയിന്റ് ഞാനത് നിങ്ങൾക്കൊരു ഗ്രാഫിലേക്ക് കൊണ്ടുവരാം. കിട്ടുന്നില്ല. ഇതെടുക്കുക. ഇപ്പോൾ ഇവിടെ ഒരു ഫംഗ്ഷൻ വാല്യൂ ഉണ്ട് എഫ് ഓഫ് എക്സ്, എഫ് ഓഫ് വൈ ആണ്. ഈ എഫ് ഓഫ് എക്സിൻ്റെ എഫ് ഓഫ് വൈയുടെ ഒരു മിഡിൽ വാല്യൂ ആണ് ഈ പറയുന്ന എഫ് ഓഫ് എക്സ് പ്ലസ് 1 മൈനസ് എ ഇൻറ്റു എഫ് ഓഫ് വൈ. ഓക്കെ, സോ അത് ചിലപ്പോൾ ഒരു പക്ഷേ ഈ ഒരു വാല്യൂ എന്ന് വിളിക്കും. ഈ ഒരു വാല്യൂ മനസ്സിലായില്ലേ? എ ടൈംസ് എഫ്, എ ലൈസ് ബിറ്റ്വീൻ 0 and 1, എ ഇൻറ്റു എഫ് ഓഫ് എക്സ് പ്ലസ് 1 മൈനസ് എ ഇൻറ്റു എഫ് ഓഫ് വൈ. പക്ഷേ ഈ ഫങ്ഷണൽ വാല്യൂ ഒരു സിംഗിൾ ഫംഗ്ഷനായിട്ട് എടുക്കുമ്പോൾ അതിന് കറസ്പോണ്ടിങ് ആയിട്ട് നേരെ താഴെയുള്ള വാല്യൂ ഏതാണ്? നേരെ താഴെയുള്ള വാല്യൂ ഏതാണ്? ഈ വാല്യൂ എന്ന് പറയുന്നത് എഫ് ഓഫ് എ ഇൻറ്റു എക്സ് പ്ലസ് 1 മൈനസ് എ ഇൻറ്റു വൈ ആണ്. ഓക്കെ, into f of x plus minus a into f of y. Okay, അപ്പോൾ നോക്കി ഏതാ ചെറുത്? എ ഇൻറ്റു സോറി ഇതല്ല, ഈ എഫ് ഓഫ് എ ഇൻറ്റു എക്സ് പ്ലസ് 1 മൈനസ് എ ഇൻറ്റു വൈ. അപ്പോൾ ഏത് വാല്യൂ ആണ് ചെറുത്? എഫ് ഓഫ് എ ഇൻറ്റു എക്സ് പ്ലസ് 1 മൈനസ് എ ഇൻറ്റു വൈ ആണ് എ ഇൻറ്റു എഫ് ഓഫ് എക്സ് പ്ലസ് 1 മൈനസ് എ ഇൻറ്റു വൈനേക്കാളും ചെറുത്. ഗ്രാഫ് നോക്കി മനസ്സിലാവും. സോ ദാറ്റ് ഈസ് ആക്ച്വലി എന്താണ്? കോൺവെക്സിറ്റി പ്രോപ്പർട്ടി. ഓക്കെ, അങ്ങനെയുള്ള ഫംഗ്ഷൻസിനെയാണ് കോൺവെക്സ് ഫംഗ്ഷൻ പറയുന്നത്. അപ്പോൾ ഈ ഒരു ഫംഗ്ഷൻ കോൺവെക്സ് ആണ്, കാരണം ഇത്രയും ഡിസ്റ്റൻസ് വ്യത്യാസമുണ്ട്, ഹൈറ്റ് വ്യത്യാസം. ചെറുത് ഏതാണ്? എഫ് ഓഫ് എ എക്സ് പ്ലസ് 1 മൈനസ് എ ഇൻറ്റു വൈ, വലുത് എ ഇൻറ്റു എഫ് ഓഫ് എക്സ് പ്ലസ് 1 മൈനസ് എ ഇൻറ്റു വൈ. അപ്പോൾ അങ്ങനെ വരുന്ന എല്ലാ ഫംഗ്ഷൻസും കോൺവെക്സ് ഫംഗ്ഷൻ. That is it. So using that convexity property, we have one important inequality, that is Jensen's inequality. Okay. So if f is convex and s dash of x is finite, then f of s dash of x is less than or equal to s dash of f of x. Okay. So we have x is a random variable and f is a convex function. Okay, you can use this convexity property, lambda x naught x minus x naught less than or f of x minus f of x naught. So you can replace x naught with s dash of x, that is a fixed value, x with the random variable x. Okay, the constant fixed value is replaced with the s dash of x, and x small x is replaced with the capital random variable x. So you will get lambda of s dash of x into x of omega minus s dash of x less than or equal to f of x of omega minus f of s dash of x. Okay, you can take the expectation on both sides, so you will get this left hand side. What will be the left hand side? So I will write that equation. The lambda ഇല്ലാത്തതുകൊണ്ട് ഞാൻ തൽക്കാലം എൻ്റെ ലാംഡ gamma of s dash of x into x minus s dash of x less than or equal to f of so you can take the expectation on both sides. Is 0. Okay, so this is 0, so this is greater than or equal to 0. Okay, so f of s dash of x, this only. So that is the result. Okay, so you will get f of expectation of x less than or equal to expectation of f of x. Okay, again we can apply this inequality format to different functional values. Suppose f of x is equal to x raised to r. First one is അത് നമുക്കിവിടെ ഒന്ന് റീറൈറ്റ് ചെയ്ത് എഴുതാം. നമുക്കിങ്ങനെ എഴുതാം അല്ലേ. So if you take the or if f is invertible, you can take the inverse is the expectation of f x greater than or expectation of f. Take f of x will be x raised to r, then expectation of x less than or equal to what is that? Okay. ഇതെടുക്കാം. X raised to r. എന്താണ് എഫ് ഓഫ് എന്ന് പറയുന്നത് x ആയിരുന്നെങ്കിൽ x raised to r ആയിരുന്നു. ഇതെന്താവും raised to r ആയി. So you can take the inequality. Again ഈ ഒരു inequality നമ്മൾ ഓൾറെഡി പറഞ്ഞിട്ടുണ്ട്. ലിയാപ്പനോ inequality 5.6.69. So that is a so if you take b equal to r and r equal to 1 here, so you will get equation 5.68, that is expectation of x less than or equal to expectation 1 by raised to r 1 by r into mod x raised to r. So that is special case of this Lyapunov inequality. Okay, I think it is clear for you. Now basic inequality, I think we have already studied that basic inequality. We have discussed and proved all this result. Markov inequality, Chebyshev's inequality, everything we have discussed. Now we consider inequalities of moments of complex dynamics. Okay. Just take c of x comma y is equal to, this is the if x and y, x, y and z are complex numbers, then the covariance of x comma y is defined as c of x comma y equal to expectation of x minus expectation of x into minus expectation of y conjugate. That is the definition. So that is expectation of x minus expectation of x into y conjugate minus expectation of y conjugate. Okay, and variance of x we denote as sigma square of x. So that is, if we replace y with x, the covariance will become variance. So covariance x comma x equal to expectation of x into x conjugate, that is mod x square. So instead of x minus s potential of x into x minus s potential x conjugate, mod of x minus s potential square and the s potential outside. So this is cx comma x. And cy comma x conjugate equal to s potential of y minus s potential of y into s potential x conjugate minus s potential x conjugate all conjugate. Okay, so we can write it as if we explore this function and apply the conjugate to all terms and then reduce to the form reduce this function as in the format of first step. So you will get s potential of y conjugate minus y s potential of y all conjugate, and this x minus s potential of x, because x conjugate all conjugate will be x itself. So you have to explore and apply conjugate and then reduce to the original form. Okay. So this is nothing but this is actually covariance x comma y. So this means covariance y comma x all conjugate to covariance x comma y, x comma y. That's the result. Now another property is covariance ax plus by comma z equal to a into covariance x comma z plus b into covariance y comma z. That is trivial. And covariance x comma x equal to s potential mod x minus s potential x square. That equal to real part square plus imaginary part square and the expectation, because mod x നമുക്കറിയാം mod z എന്ന് പറയുന്നതാണ് x square plus y square ആണ്, root of x square plus y square ആണ് mod x എന്ന് പറഞ്ഞാൽ. mod z equal to square root of will be mod x square plus mod y square. Okay. അപ്പോൾ മോഡിൻ്റെ സ്ക്വയർ എടുത്താലും സ്ക്വയർ തന്നെയായിരിക്കും, അതുകൊണ്ട് യു സ്ക്വയർ പ്ലസ് വി സ്ക്വയർ ഇങ്ങനെ എഴുതി. So covariance x comma x will be 0 when both these terms are 0. That is, s potential of u square is 0 and s potential of v square is 0. U square 0 means s potential of u square 0 means u equal to 0 almost surely, and s potential of v square 0 means v equal to 0 almost surely. That means x minus s potential of equal to 0 almost surely. That is, x equal to s potential of x almost surely. So that is the result. Okay. And the last one is, this is what is that? Using which inequality. So what is s potential of alpha x mod x minus mod y square, a plus b all square, a square plus b square, a minus b all square, a square plus b square minus 2ab. So you can use that result. So alpha square is mod x square plus but this is square expectation square. Okay. Then take alpha equal to expectation mod x area expected x square. Alpha equal to എടുക്കും. മോഡ് കിട്ടാൻ കുഴപ്പമില്ല, സ്ക്വയർ വരുമ്പോൾ പിന്നെ മോഡൊക്കെ ഒഴിവാക്കും. എന്നാലും ഇനി നമുക്ക് ഫോർമാറ്റ് എഴുതാം. സോ എന്തായിരിക്കും ഓക്കെ. ഇത് ഈ എക്സ്പെക്റ്റേഷൻ എക്സ് സ്ക്വയർ നമുക്ക് കോമൺ ആയിട്ട് എടുത്താൽ എന്താവും? ഇവിടെ വരും. ഇതിന് മൊത്തത്തിലാവും. പിന്നെ ഓക്കെ. ഇങ്ങനെ വരും. അപ്പോൾ അതിൽ ഇത് ക്യാൻസൽ ചെയ്യാം. ഒരേപോലെയുള്ള എന്താ ആൽഫ ഈക്വൽ ടു അതിൻ്റെ ഒരു സ്ക്വയർ ഉണ്ട്. സ്ക്വയർ ഉള്ളപ്പോൾ ഇത് മുഴുവനായിട്ടും പോവില്ല, ഒന്നും ഇവിടെ ഉണ്ടാവും, ബാക്കി ഒന്നും ഇവിടെ ബാക്കി ഉണ്ടാവും. ഇല്ല, ഇതൊന്നല്ല പോലും, ഇതിൽ രണ്ടെണ്ണം വന്നു. ഇത് സ്ക്വയർ അല്ല വരിക. ഒന്ന് പോയി കഴിഞ്ഞാൽ ബാക്കി ഓരോന്നിനും നമുക്ക് ഇവിടെ വെച്ച് ക്യാൻസൽ ചെയ്യും. ഇവിടെ നമുക്ക് ഇത് കളയാം, അതുപോലെ തന്നെ ഇവിടെ ഒന്ന് കളയാം, അത് താഴെയുള്ള ഇത് ഒന്നായിട്ട്. ഓക്കെ, അപ്പോൾ എന്തായി നമുക്ക് കിട്ടുന്നത് അതന്നെ ഇവിടെ 2 പ്രാവശ്യം സ്ക്വയറിനാണ്. ലെഫ്റ്റ് സൈഡിൽ നിന്നൊന്നും റൈറ്റ് സൈഡിൽ നിന്നൊന്നും ക്യാൻസൽ ചെയ്താൽ ബാക്കി ലെഫ്റ്റ് സൈഡിൽ 2 ഉണ്ട്. അപ്പോൾ അതുകൊണ്ട് ലെഫ്റ്റ് സൈഡിൽ നിന്ന് 1 ക്യാൻസൽ ചെയ്യുക, റൈറ്റ് സൈഡിൽ നിന്ന് 2 ഉള്ളതുകൊണ്ട് റൈറ്റ് സൈഡിൽ 2 നിന്ന് 1 ക്യാൻസൽ ചെയ്യുക. അപ്പോൾ ബാക്കി വരുന്നത് ആണ് ഇങ്ങനെ വരും. ഇതിൽ 2 പോകും, മനസ്സിലായില്ലേ? സോ യു വിൽ ഗെറ്റ് ദിസ് സ്ക്വയർ എഴുതാനുള്ള എക്സ്പെക്ടേഷൻ ഓഫ് മോഡ് എക്സ് വൈ ഹോൾ സ്ക്വയർ.